My name is Katia. I'm doing master degree at UFPE in the area of civil engineer. My master advisor is Professor Leonardo Guimarães, and I will present the progress of my research, which is about experimental study of tension and deformation of a synthetic carbonate rock during the chemical dissolution. The injection and extraction fluid oil reservoir can cause the mineral dissolution, changes in pressure, temperature, and saturation that affect the stress state, resulting in reservoir rock strain, as well as change in the permeability and porosity of the porous medium. In this context, the physical and chemical mechanics in the rock-fluid interaction affects the mechanical behavior of the rock, reducing its strength when subjected to the different load conditions, and can thus lead to a weakening for the loss of stiffness and mechanical strength. Thus, the main objective of this research is to study the stress and strains of a synthetic carbonate rock during the dissolution of minerals from the oedometer tests in order to represent and understand the geomechanical and geochemical behavior of the rock during the dissolution of minerals. For this purpose, dissolution tests were performed using a synthetic carbonate rock by a modified oedometer cell, allowing a controlled flow and acidic solution through the pores of the sample. The dissolution tests were carried out in two steps: total dissolution and partial dissolution. From the results of the mineral dissolution test, it was observed that the residual stress increases linearly. Also observed a volumetric strain at 3.9% and 11.51% for the total and partial dissolution, respectively. Through the unconfined compression test, it can be seen that the strength of the synthetic sample reaches a value of 3,530 kPa before the dissolution process. On the other hand, after the mineral dissolution, there was a decrease in resistance by 22% and an increase to 46.4% of the porosity rock. Thus, this fact can lead to chemically induced compression of the reservoir when submitted to fluid injection that can chemically interact with the porous medium. Thank you for your attention.